Hello everyone, my name is Amir. Today I'm gonna talk about the problem number 23 of chapter 3. The problem is that the position of a particle as a function of time is given by r equal 5i plus 4j t squared in meter vertices in seconds. A. What is the particle's distance from the origin at t equals 0, 2 and 5 seconds? B. Find an expression for the particle's velocity v as a function of t. C. What is the particle's speed at t equals 0, 2 and 5 seconds? For the A, we have to find the distance from the origin at 3 points. Our equations is in terms of I and j. That means it's for the displacement. So we need the distance equation. For finding a distance equations, we need to find the magnitude of our r equation. So it's going to be a square root of 5 squared plus 4 squared to the t squared, which our distance equation is going to be r equal square root of 41 to the t squared. After that, we just need to plug in our numbers into our distance equations. For t equals 0 seconds, r is going to be a square root of 41 to 0, and the result is 0 meter. For t equal 2 seconds, our r equation is going to be r equal square root of 41 to 2 squared, which is the same as square root of 41 to 4, which our r result approximately is 25.6 meters. For our last number, which is 5 seconds, our r equation is going to be 2 equal square root of 41 to 5 squared, which is the same as the square root of 41 to 25, which our result approximately is 160 meters. For B, we are asked to find an expression for the particle's velocity v as a function of time. So we have our equations in terms of m or meters. That means it's for the positions. For finding a velocity, we just need to get the derivative of our equations in terms of t. So for finding a derivative of our r equations, we just need to assume that this one is the constant because there is no t inside of this parenthesis. So our result is going to be 5i plus 4j to 2t, because t squared, our derivative of t squared is going to be 2t. Or if you for more simplify, you can just multiply these two inside of this parenthesis. So it's going to be 10i plus 8j to t in meters per second. For the part C, we have to find the particle's speed at t equals 0, 2 and 5 seconds. So we have the velocity equations in terms of I and j again. So we need to find the speed. For finding a speed, we just need to get the magnitude of our velocity equations. So it's going to be the square root of 10 squared plus 8 squared to t, which is the same as this one. So for the final steps, it's going to be just plugging our numbers into our speed equations. So for t equals 0 seconds, it's going to be a square root of 164 to 0. Our result is 0 meter per second. For t equal 2 seconds, our result is a square root of 164 to 2, or approximately 25.6 meter per second. For t equal 5 seconds, our result is a square root of 164 times 5. The approximately result is going to be 64 meter per second. I hope all this information and solution are helpful for you. Thank you.